Okay. So we know what a function is, right? It's a set of inputs, each of which has exactly one output, okay? Now they're going to talk about domain and range, right? So the set of inputs, right, is called our domain, the domain of our function. And all of the outputs, the y values, are called the range, all right? So in other words, the domain, okay, is a set of all inputs, all possible inputs. And sometimes there's restrictions on that, right? Set of all inputs, or X. And the range is the set of all outputs, or Y values, okay? And you need to be able to keep track of which is which, domain and range. So domain is X, and range is Y. And we're going to give some, we're going to give you some notation you might not have seen before or not too often, but we'll get to that in a minute, okay? So in exercise 1, they want us to state the range of the functions. Range of the function f of n equals 2n plus 1. If its domain, the domain is what? What values?
1, 3, and 5.
Well, yeah, but generally x or y.
X.
So this is a sample x, another sample x, another sample x, right? That we put in and get the y out of it, right? Or f of n. In this case, it's a sample n. We're using n, okay, instead of x, but it works the same. Okay. So let's figure out then what f of 1 is. F of 1, right, would be 2 times 1 plus 1, which is, of course, 3. F of 3, 2 times 3 plus 1, which is, well, you guys are slow. 7? Okay. And then f of 5 be 2 times 5 plus 1, which is 11, right? So let's list our domain in this first oval here, right? So our domain was what? 1, 3, and 5. And that results in a range in this case of what?
3, 7, and 11.
3, 7, and 11, right? They correspond with one another. So that's one simple way to list our domain and range, okay? We won't do it that way too often, right? I'm going to give you something called set builder notation, right? And you know about the number system, right? We've talked about the real number, set of real numbers. That's like all the numbers we use in day-to-day life. You know, 1, 2, 3, -5, you know, 6.14, pi, that kind of thing. They're all real numbers. Integers would just be all the non-decimal numbers, right? Okay, so you know, kind of familiar with those sets, right? Anyway, we're going to be working predominantly in the real number system here, and not the imaginary or complex, which we'll get to later on, hopefully. Okay. So down here in example 2, we've got a function y equals g of x, and it's graphed over here. Okay. For any of you that move on to physics or something, that looks like either a sine or a cosine curve of some kind. But anyway, answer the following question. So let's determine the minimum and maximum x values represented in this graph. Now notice there's no arrows at the end of it, right? You guys notice there's no arrows here? So that means it starts and stops. And those circles, do you recall, like at the end, like here and here are closed? You know, they could be open, right? Does that sound like familiar? So what are the minimum and maximum x values? What's the min x?
The min x is -3.
-3, okay? And our max would be an x of what?
Five. Wait, no, 6.
6, wouldn't it be? Okay? So we can describe our domain as follows, okay? This is probably a different notation than you've seen, okay? So it's going to use like a set of squiggly brackets, okay? So we could call our domain like this, domain, squiggly bracket, okay? And I'm going to write the following. X, that vertical line, okay? -3 less than or equal to X less than or equal to 6, right? And I might add, and we won't always have to do that. I'll do it in the next example. I won't add it now. Okay? Okay? So this is called set builder notation. Have any of you guys seen this before? I guess not. Well, now you have. Okay? So the way we read this is as follows. Here's how you would read this. All X, and this vertical line stands for a word, all X such that. Okay, that vertical line means such that. X is in between what?
-3 and 6.
-3 and 6. And now one thing we have to add here, you notice the less than symbols both have the equal sign there, right? So if it's less than or equal to, you know that it actually includes -3 and includes -6, right? So we would say all X such that X is between -3 and 6 inclusive. Okay, does that make sense? That vertical line is just read such that. Okay? So should be a little bit familiar with that set builder notation. It's not that difficult, I don't think. Okay? Now let's go on to part B. So now we're going to be talking about the minimum and maximum Y values, right? Or the domain, right? So let's look at our graph. And for a minimum Y value, what do we have? For the lowest Y value on that graph?
-5.
-5 down here, right? -5. And what's our max? It's the highest Y value.
3.
What is it?
3.
You sure about that?
Wait, no. 4.
All the way out here, right? That's the highest one. Okay? So it would be 4. So let's do a set builder notation for range. Okay? So instead of X, we're going to use what?
Y.
Y. So all Y such that, what should I write?
-5.
-5.
In between.
Well, I'm not going to write words in between. I'm going to use the notation I did up there.
Yeah, notation.
So what am I going to write?
What more or equal?
Less than or equal to
Y.
Y
And more than equal.
less
or
than
equal
or equal
Then.
to
4.
4. Okay? So that's how we would write the range for this. Okay? And you know it's the range. Like even if I didn't write the word range here, you know it's range because what does it lead with?
Y.
Y. And up here, you know it's a domain because it leads with
X.
X. Okay? So you don't really have to write the words range and domain. Okay? All right. So they want us to state the domain and range using set builder notation. I've already done that, but we're going to enhance it just a little bit. Okay? So we need a little bit of symbolism here. So we already know what the vertical line means, right? That means what? That vertical line means what? Let me see it.
That is the function.
No, just such that. The word such that. Like all X, such that, right? The vertical line means such that. Okay, so we got that part here. Now, we also need to use, there's some symbols here. That silly looking kind of E thing, right? This means is an element of. Okay? And usually it's going to be followed by some set of numbers like real number set or integers or whole numbers or something like that. Okay? And there's a particular symbol for the set of real numbers. And it's this like double-lined R thing. Okay? That's the symbol for the set of real numbers. Okay, so we're going to incorporate those two things into our set builder notation. Okay, so let's do the domain with the X then. So here's how it'll look. So it'll be all X. It'll be a lot like what we had up there, right? Such that, right? What was it? -3 less than or equal to X less than or equal to, what was it, 6, right? And I'm going to put comma, and I'm going to state what set my X's belong to. So X is an element of the real numbers. Okay, so we've added a little bit to that notation. Okay, so that would be like the complete, exhaustive set builder notation thing. Okay, and let's do the range. It'll be all Y such that -5 less than or equal to Y less than or equal to 4, comma, Y is also an element of the set of real numbers. Right? You have to specify that, right? Because sometimes, the function might say, okay, no, it's just the integers or something like that, like nothing in between whole numbers kind of thing, right? All right, so hopefully you can get comfortable, familiar with reading that kind of notation and probably writing it. Okay. What do they have next? Yes, a different type of notation. There's another notation that'll kind of tell us the same thing that we just did with set builder notation. Okay. And this I think you've seen. So let's go to the top of the next page. It's this interval notation. Okay. So we need to know this as well. Okay. So generally, what you put in here is some min value and max, right? Min comma max, like from like what was it? It'd be like from what we had, like -3 up to -6, and then how do we handle whether it's just like less than or equal to, right? So notice when we have these hard brackets, it includes those endpoints, right? This would be like the less than or equal to, right? And when it's just the regular parentheses like this, it's not inclusive, right? So this would just be the equivalent of less than, less than. Does that make sense? If we were to write it in set builder notation, the hard brackets would be inclusive, right, with the equal sign. And the soft parentheses would be non-inclusive without the equal sign, not including the endpoints, like right up to them, like 0.99999, but not actually hitting that integer. Okay. Let's see that. Oh, and by the way, let's say a graph goes off to infinity, and I have the domain or range. Can we ever actually include infinity?
No.
In our set? No, because by definition, you can never reach it, right? It's one of those weird mathematical concepts, okay? So whenever you have infinity, you know the symbol for infinity, right? That sideways 8? And we have positive and negative infinity, so you can never actually include infinity. Let me just jot that. So infinity can never be inclusive. Right? So you'll never have, like less than or equal to infinity, right? That kind of thing. Because you'll never get there. So let's look at the graph here. They want to know which represents its domain and range. Okay. So take a look at our graph. The domain, and notice it has arrows at the end, right? The domain is going to be all the possible x values. What would you say the lowest and highest x values could be for this relationship? How far? Left.
The lowest is -2.
Now be careful. You see those arrows? Doesn't that graph keep getting wider and wider and wider?
So it's infinity.
Yeah. So wouldn't the domain go from negative infinity to infinity?
Yes.
Right? Okay. So what about the range then? The y values. What's the lowest y value?
-4.
So down here is the lowest. Now, does it include -4? Is that a closed circle?
Hmm. Hmm.
Is that a closed circle there at the y of
Yes,
-4?
a closed
Yeah,
circle.
so what actually includes, it's inclusive of -4. And what's
So the
the
range is -4 to infinity.
positive infinity, right?
Positive infinity.
Would be the max, okay? So what choice here would represent the domain and range?
Number 3.
Okay, everybody get that? And notice how they use this bracket here. On the negative, like the -4 to infinity, right? That's our min max. And this means inclusive, right? And this is not inclusive because we can't include infinity, right? Okay, so it'd be choice 3. So be comfortable with that notation as well. So down here, I almost got this in the bag here. They talk about the set of real numbers right here. So that's that double line to R I told you about, the set of real numbers. Okay. Before we get to the next example, I want to give you a quick note on things, just make sure we're all on the same page. There are certain restrictions on our functions, right? Let's go over to page 23 real quick. Certain things we cannot do in math. Can we divide by 0?
No.
No. So division by 0, anything divided by 0, the result is what we call undefined. Right? So you can't have something like 5 divided by 0 because that's undefined, right? It's not possible in mathematics. Okay? And you all kind of know why that is, right? But let's say, just some of you don't know, it's not like just a random rule. Let me give you this. If I said like 8 divided by 2 equals 4, right? What does that imply, guys? That implies that 4 times what?
4 times 2
2
equals 8.
equals 8, right? That's what that
But
implies.
you can't times 0.
Right. So, like a lot of people think that 8 divided by 0 would equal 0, right? But what would that have to imply?
0 times 0 equals 8.
That's what, right? And it does not, right? So that's why we cannot divide by 0. Right? That's one of the simple explanations. There's other more complicated explanations of that, but I think that'll suffice. And also, let's talk about taking the square root of a negative. Square root of a negative number. Okay, so we know that the square root of 16 is plus or minus 4, right? And you get 2 answers there, don't you? Now, what does that imply? That 4 squared equals what?
Equals 16.
Positive 16, right? And what else?
And that -4 times squared equals 16.
Right?
Positive 16.
Because when you square something, it's the thing times itself, right? And a negative times a negative is always a what?
Positive.
All right? So let's do this. This is something I see kids do. If I took this, try to take the square root of negative 16 and say, okay, that's negative 4, right? Well, wouldn't that have to imply then that negative 4 squared, right, equals negative 16? That's what that would have to imply. Is that possible?
No.
No, right? Because a negative times a negative, right? Because negative 4 times negative 4 equals positive. Whoop, not plus or minus. Negative 4 equals positive 16. Okay? So in the real number system, you cannot take the square root of a negative. There is an imaginary and complex number system whereby we can. So like if anyone ever goes into, say, like electrical engineering, and you're modeling, schematics and circuits and things like that, it turns out that somewhere in the midst of that modeling, you do have to take the square root of a negative, and there has to be a way to handle that. And then hopefully your final result, eliminates that, and you end up with a positive number. But we'll deal with that later, right? But in the real number system, you cannot take the square root of a negative. So these are two things that would be like restrictions on a domain and range, okay? Like if something like that were to happen, we'd have to put a restriction on our domain and range. So let's go back then to this example here. Now we have our function f of x equals 2x plus 1 over x minus 4. Okay, that's division, right? Everybody agree that's division? And what can we not divide by?
0.
0, okay? Now they've put this in their calculator, said, right? And over to the right here, they have a table of values. You've all done that on your calculator, okay? They want us to evaluate f of 1 and f of 6. So looking at that table of values, what does f of 1 equal?
-1.
-1. And what does f of 6 equal?
6.5.
6.5. Good enough, right? Not a problem there. Now their calculator gave an error at x equals 4. Why would that be? What would cause a problem with that function?
-4, like 4 minus 4 equals 0.
Right. If I put an x of 4 in there, that becomes a 0 in the denominator, right? And you cannot divide by 0, right? So f of 4, if we plugged it in, right? F of 4 would equal 2 times 4 plus 1 over 4 minus 4, right? Which would be 9 divided by 0, which is, of course, what?
Undefined.
Undefined. Your calculator doesn't say undefined, it just says error, okay? Because we cannot divide by 0. By 0 in the reals. Okay? Now part C. Are there any values except 4 for x equals 4 that are not in the domain? Are there any, in other words, are there any other x values that would cause a problem in that function?
No.
No. X equals 4 is the only input that would make the denominator what?
0.
It's the only input. I can't write today. Input that would make denominator 0. Okay? So let's write down our set builder notation, like the range. We have to exclude x, don't we? So let's do our set builder for the possible x values. Okay? So it would be all x such that, well, we know it can go from negative infinity to infinity, right? Negative,
You go range.
huh? Or domain, I'm sorry. Whoopsie daisy. You got me. You made a fool of me. Domain. Right, be all x values, right? Negative infinity less than x, less than positive infinity, right? And x is an element of what number system? Reals. And what's our restriction here? X cannot equal what?
4.
4. So do you see how we enhance our set builder notation for that? It looks like a lot, but I think we've done it step by step. You kind of get it, right? All right. Let's take a look at example 5 and we'll put a bow on this thing. Now we have a square root, right? Which of the following values of x would not be in the domain of the function? In other words, what value of x would cause a problem here? What causes a problem with square roots, guys?
4
No.
on the negative 8.
No, just generally. Forget that. What causes a problem when you're taking a square root?
A negative number.
So could x equal 4 in this? Can we take the square root of 0?
Yes.
Yeah, square root of 0 is 0, right? There's no problem there. Okay. So x can equal a whole lot of things, can it? What are some examples of what x cannot equal? It could be
For
negative 4.
example, negative 4.
It could be negative 4.
Oh no, negative 8. I mean, so
So what happens if x is negative 8? Let's try these here. So let's look at number 1, right? The square root of 0 plus 4, right? Well, that's just the square root of 4, isn't it? That's fine. Let's try this one. That'd be the square root of 5 plus 4. That's the square root of 9. That's not a problem. Let's try choice 3. That'd be the square root of negative 3 plus 4. Right? That's the square root of 1. Is that a problem? This one, negative 8 plus 4. That'd be the square root of what? Negative 4. That's a problem, isn't it? Okay? So in other words, x cannot be less than negative 4. That makes sense to you guys? Okay.
yes.
Well, there's 3 assignments here now. Let's try at least get the first 2 done by 9:45, and then maybe we'll save this third one here for Monday. Okay.